Explorer-1, NASA's farthest traveling spacecraft, is still journeying through the vast, unexplored regions of the universe nearly 50 years after its launch. Recently, scientists have been alarmed by the strange signals it's sending back to Earth, possibly due to a malfunction. Let's delve into the mysterious data Explorer-1 has been transmitting during its extended space exploration. Launched in 1977, the Explorer-1 was part of a twin mission alongside Explorer-2. The two spacecraft were launched from the NASA Kennedy Space Center, with Explorer-2 leaving first on August 21, 1977, followed by Explorer-1 2 weeks later. Both probes weighed approximately 720 kilograms, similar to a small car. They were launched during a special planetary alignment, which provided a slingshot effect to send the spacecraft from one planet to another. Despite their similar start, they have traveled on different paths and speeds. On December 15, 1977, Explorer-1 overtook its twin and began to serve as an invaluable tool in studying distant realms of space. It played a significant role in planetary research, particularly with its Jovian imaging mission in 1978, where it captured over 3,700 images of Jupiter and its moons. In addition to capturing time-lapse films of Jupiter's rotation, it made groundbreaking discoveries, including the detection of 2 new moons. It also helped identify Saturn's moons and a faint ring around the planet. After its Saturn mission, NASA transitioned the spacecraft to an interstellar mission in 1990, beginning with the famous family portrait image of the solar system. Taken from over 6 billion kilometers away from the Sun, these photographs became iconic, representing the farthest view of the solar system ever captured. However, the cameras were eventually turned off to conserve energy as the spacecraft journeyed farther into space. Explorer-1 continued its journey for years, eventually entering interstellar space on August 25, 2012. However, NASA did not announce this milestone until 2013. By November 2018, both Explorer-1 and its twin had officially crossed the heliopause, entering the interstellar medium. At this point, Explorer-1 was around 145 billion miles, or 550 million kilometers, from Earth, providing valuable data that no other mission could. The spacecraft has spent most of its journey in good health, but recent anomalies have raised concerns. Recently, it has been transmitting strange signals back to Earth, with its readings not matching the expected conditions. Despite this, the spacecraft's communication system is still functioning, and it is continuing to send data. What's puzzling scientists is that despite the apparent discrepancies, Explorer-1 has not entered safe mode or triggered any emergency alarms, which are typically programmed to occur when a malfunction happens. The spacecraft's antenna, responsible for transmitting data to Earth, seems to be in good working condition, but the data being sent is increasingly unusual. The spacecraft continues to receive instructions from Earth and execute them, but the control system's readouts do not fully align with the spacecraft's actual status. According to a NASA official, the exact cause of the problem remains unclear. Another intriguing feature of Explorer-1 is its golden record, a 12-inch gold-plated disc that holds various audio and visual messages for potential extraterrestrial life. It includes greetings in 55 different languages, music, photos, and messages from former U.S. President Jimmy Carter and UN Secretary-General Kurt Waldheim. This has fueled speculation about alien interference with the spacecraft, but scientists quickly dismissed this theory. Explorer-1's current performance is puzzling, as the spacecraft's attitude and control system seems to be functioning properly, adding to the mystery. Moreover, none of the safety protocols designed to protect the spacecraft from harm have been triggered. Project manager Susan Dodd acknowledges that the spacecraft is far beyond its expected lifespan and that the team will face significant challenges in troubleshooting the issue, especially given its distance from Earth. At approximately 145 billion miles from Earth, any attempt at a rescue mission is virtually impossible. The sheer distance presents a major obstacle to resolving the issue, and the spacecraft is now far beyond the reach of any spacecraft or repair mission. As Explorer-1 continues its journey into the unknown, scientists remain puzzled by the strange data it continues to send, marking the latest chapter in the remarkable, The journey of Explorer-1 has taken it far beyond the familiar boundaries of our solar system, reaching the fringes of interstellar space, where it continues to travel further away from Earth each day. Messages sent from Earth at the speed of light take nearly 21 hours to reach the spacecraft, meaning that any commands or instructions sent from the engineering team face a significant delay in being received. This delay poses a considerable challenge for real-time problem-solving and troubleshooting. Furthermore, once Explorer 1 processes the commands, any response or data it sends back to Earth takes another 21 hours to return, resulting in a two-way communication delay of about 2 days. This extensive lag makes it incredibly difficult to perform quick fixes or iterative troubleshooting processes, which are often essential for addressing complex technical issues. In contrast to missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay with Explorer 1 requires a more careful and patient approach. Every instruction must be meticulously planned to address known issues without introducing additional problems, given the lengthy wait to confirm whether the command had the desired effect. The delay also limits the engineering team's opportunities to interact with the spacecraft, making every command crucial, with little room for error. As a result, extensive testing and validation of commands on Earth must take place before they are transmitted to Explorer 1. Adding to these challenges is the fact that Explorer 1 is over 45 years old, having been launched in 1977. While its technology was cutting edge at the time, by today's standards, it is considered outdated. The engineering team is working with systems and hardware designed in the 1970s, which complicates the troubleshooting process. Additionally, the harsh environment of space has caused significant wear and tear on the spacecraft's components. Explorer 1 has been exposed to high levels of radiation, extreme temperatures, and micrometeoroids for decades, which have contributed to the degradation of its systems, making maintenance and repairs even more difficult. Despite these obstacles, the engineering team remains committed to solving the problems that have arisen. They are exploring various hypotheses to determine the cause of the anomalies and are testing potential solutions through simulations on Earth. This careful, methodical approach is essential, as any incorrect command could worsen the situation or even result in a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer 1 systems, which were designed to enhance the spacecraft's resilience to failure. If a specific component is found to be malfunctioning, the team may be able to switch to backup systems and restore normal operations. In summary, while diagnosing and fixing the issues with Explorer 1 presents tremendous challenges, the engineering team is leveraging their expertise, experience, and the spacecraft's inherent resilience to overcome them. Their meticulous and patient approach is critical in managing the vast communication delay and the complexities of working with a spacecraft that is both distant and aged. Despite these challenges, the team's efforts aim to extend Explorer 1's legacy of exploration and scientific discovery, far beyond its original mission parameters. The anomalies currently affecting Explorer 1's telemetry data could be the result of cosmic rays interacting with the spacecraft's delicate electronics. These high-energy particles, originating from distant supernovae or other astronomical events, travel through space at nearly the speed of light. When these particles strike Explorer 1, they can penetrate its exterior and affect the internal electronics. The longer the spacecraft remains in space, the greater the likelihood that cosmic rays will impact its systems over time. This phenomenon can lead to irregularities, such as those currently observed in the spacecraft's data. Engineers have long been aware of the potential risks posed by cosmic rays to spacecraft electronics, as well as to human travelers. However, predicting and mitigating their impact can be difficult. Despite these challenges, engineers have implemented various measures to protect spacecraft from cosmic rays, such as shielding sensitive equipment, designing redundant systems, and using error-correcting codes in data transmission. Nevertheless, even with these precautions, cosmic rays can still pose a threat, especially to spacecraft operating in deep space for extended periods like Explorer 1. Although the recent anomalies in Explorer 1's data are puzzling, they are not entirely unexpected given the spacecraft's age and prolonged exposure to cosmic rays. Scientists and engineers continue to monitor the situation, analyzing the data received from Explorer 1 in an effort to pinpoint the exact cause of the anomalies and develop strategies to mitigate their effects on the spacecraft's operations. Despite these difficulties, Explorer 1 has far surpassed its original mission expectations and continues to provide valuable insights into the outer regions of our solar system and beyond. Its accomplishments are a testament to the ingenuity of its creators and the dedication of the team that has supported it for over 4 decades. Explorer 1's journey serves as a reminder of humanity's enduring curiosity and determination to explore the uncharted realms of space. And as we look toward future missions, spacecraft like Explorer 1 will continue to expand our understanding of the universe.